Hello guys, welcome to your channel which is SciEngineers. This is Sushant. We have been uploading videos for Mhtcet 2020 for the mathematics section, and in the last video we had seen the topic which is differentiation. This particular video is also going to be related to differentiation, but we will be concentrating on some conceptual level problems. So hit the like button, do share with your friends our videos, and do subscribe to our channel. To never miss a notification, please do hit the bell icon which is just beside the subscribe button. And also stay safe in this particular situation. So let's get going. So we'll be seeing the first question, which is if my y is equal to sine x theta. So this is, you have to understand that my x over here is given in degrees and u is equal to cos x. So here there is no degree term which is given, so we usually understand that the term is in radians. Then dy by du is asked, that is derivative of y with respect to u is asked in this question. So just let us take the question. So y is given to us as sine x theta. Now the formulas which are given basically, that is derivative of sine x and derivative of cos x, in that my x is always in radians. That is what the concept is. So here the important concept is we have to convert my degrees to radians. So the conversion of degrees to radians, you can just recollect, like if you have a theta which is given in degrees and I need to convert into theta which is in radians, we use the term which is pi by 180. Okay, so if I want to convert any angle which is given in degrees to radians, I have to just simply multiply by pi by 180. So in this case also we will be converting this x which is in degrees to the radian form. So this becomes sine pi x upon 180. So this becomes the angle in radians. So now we can directly take the derivative of this. So we have now y which is sine of this thing, and I need to find dy by du. So there is another concept which is dy by du, finding dy by du. So you know the formula, or the concept basically is, since my y is function of x and also u is also function of x, so it's like a parametric form which is given to us. So we'll be applying the formula for parametric form, so that will become dy by dx upon du by dx. So that means basically I have to take derivative of y with respect to x and derivative of u with respect to x, and I have to simply divide them. So now we have y, so taking the derivative of y with respect to x, so I'll be getting the derivative of sine is cos, so that becomes cos pi x upon 180, and since x is multiplied by pi by 180, I'll be having the pi by 180 also outside. Now here, if you just look out for the options which are given to us, we have a term which is x degrees. That means basically my x is again going back to, they have given it in the degrees form. So again you can see over here, this thing is also to be converted to degrees form. So we have to convert this into degrees form. So that becomes cos x degrees, and we have the pi by 180 outside. Next we go for the derivative of u. So that's simple because it's in normal form, because the x over there is in radian form. So du by dx is nothing but going to be minus sine x. That's derivative of cos. Now applying this formula, that is dy by du, the parametric form formula. So dy by du is equal to, I'll be simply just substituting, that is dy by dx, which is this. So it becomes cos x degrees pi by 180 divided by, we have this du by dx which is minus sine x. So the sine x goes up and we have the answer, which is minus pi by 180 cosec x cos x degrees. So if we just check out the answer is nothing but C. Going for the second one, so we have the function which is f of x, which is given to us as g of x plus g of minus x by 2 and plus 2 upon h of x plus h of minus x inverse. And here the main thing which is given to us is that g and h are differentiable. That means basically we can find derivative of those functions. Now that is very much important term which is given, important statement which is made, and I need to find f dash of 0. So you can just recollect f dash means its derivative. It's the first derivative which is asked for this particular function. So now since f dash of 0, the 0 means we have to find the derivative of the function and then we have to replace x with 0 or substitute x with 0. So now first, before going ahead, let us just think on this term. Now this is the unnecessary part which is given, like it's not, it can be simplified because it is 1 upon h of x plus h of minus x raised to minus 1, which can be written, so just rewriting the function. So it is h of x, f of x is equal to g of x, g of minus x by 2 plus 2. Now since this is 1 upon inverse, so the inverse basically goes up, so it becomes h of x plus h of minus x. So now this is much easier to analyze. So I just take derivative, so derivative of this with respect to x, so that gives us g dash of x. Now over here we have the g dash of minus x. Now within the function or within the bracket we have a minus x, so we have to take the derivative of minus x also. So that is why we get this minus term outside, and this 2, which is a constant, it remains as it is, plus again it's in that form, that is 2 outside, 2 is constant, h of x becomes h dash of x. And here also, just like this, we'll be having minus h dash of minus x. Now after this I need to just find f dash of 0. That means I have to just substitute x is equal to 0. So I'll be getting this as h dash of 0, g dash of 0 minus g dash of minus 0. So minus 0 does not make sense. It's nothing but g dash of 0 plus 2 h dash of 0 minus h dash of 0. So you can see that basically it gets cancelled out and I'm getting the answer as 0. Okay, so these questions, these types of questions can also be asked. You have to just keep your head cool while solving these type of questions. Now these two questions are very much concept driven. It's like almost deriving the particular thing, that is particular equation from there. So just let us try to analyze what is asked. It's asking us the double derivative of x with respect to y, and these options are given to us. Now in the options you can see that it is double derivative of y with respect to x. So it's basically changing the with respect to part. Here the with respect to is y and the answer is given in terms of with respect to x. So basically that should make you think on the formula, which is dx by dy is nothing but 1 upon dy by dx. So this is the starting point which is going to be there. So if you don't start with this, then you will not get the answer, or you would get basically a wrong answer, because you might think that it is A, but it's not actually A. It's going to be something else, which we are going to be just seeing in this couple of minutes. So we start with dx by dy is 1 upon dy by dx, and I need to find the double derivative of x with respect to y. So I will basically differentiate this with respect to y. So now if I differentiate this with respect to y, this becomes d square x by dy square is equal to, I will just write it in this, that is d by dy. So it's derivative of the term which is 1 upon dy by dx with respect to y. Now the derivative of 1 upon, so don't get confused with this is just like 1 upon x, we have to derivate it or differentiate it. So derivative of 1 upon x, we know that is 1 minus 1 upon x square, so that becomes minus 1 upon dy by dx the whole square, into I need to find the derivative of this term also, so that becomes d by dy into dy by dx. So I need to find the derivative of dy by dx with respect to y, so that's very much important. So now continuing with this, that is d square x by dy square is equal to minus 1 upon dy by dx the whole square into, now what we'll do is we'll be using the chain rule over here. Now since this derivative is dy by dx, that's derivative of y with respect to x, what I will be doing is I will be changing or using the chain rule over here. So the chain rule can be used in this format, that is instead of differentiating instead of differentiating it with respect to y, I will be differentiating it with respect to x. So it becomes d by dx of the function, that is dy by dx, into dx by dy, because basically we have to find the derivative of this with respect to y, so I'm just using the chain rule. So this is how the chain rule looks like. So now here you can understand it's nothing but the double derivative, that is d square y by dx square. And now dx by dy, which you can see it's nothing but 1 upon dy by dx. So this is what the final result is basically. So this gets multiplied, so we have minus, so this becomes cube and that goes up, so it becomes dy by dx the whole raised to minus 3 and a d square y by dx square. So if you just see or look for the option, you can see it's nothing but option D. Now going for question number 4, this is another the same type of question. We have x which is phi of t and y which is xi of t. So you can see x is function of t and y is function of t. So it's basically parametric form. T is a parameter. And I need to find the double derivative of y with respect to x. So now you have to understand the options which are given. They have given dashes and double dashes. That means it's single derivative and this is double derivative. So double dash means double derivative and a single dash means a single derivative. So if I want to find, so whenever we have to go for double derivative, we have to find the first single derivative, that is I need to find dy by dx. So in this case dy by dx, since it is in the parametric form, it will be dy by dt upon dx by dt, right? So now dy by dt, so that means you have to differentiate y with respect to t. So that's basically going to be xi dash of t. So do you agree with that? Now going for next, we will be going for the derivative of x with respect to t. So that means it's becoming phi dash of t. Okay, understanding? Okay, so this is what is basically my first derivative. Now I need to go for the double derivative. I need to find the derivative of this one more time. So going for the double derivative, so d square y by dx square is going to be d by dx of phi dash upon xi dash upon phi dash. So you have to understand that this is still a function of t. That's it's the main function or the main variable, it's t. So now differentiating this, so this you can see it's u by v. So first let us concentrate on this u by v. So u by v rule, you know it's derivative of the numerator, so I have to differentiate the numerator first. So if I differentiate a derivative, I get basically a double derivative. So that means I get xi double dash into denominator, so that means phi dash, minus derivative of the denominator, so that means it's double dash of phi and single dash of xi upon this thing, that is square of the denominator. Okay, so now as I said that these functions are of t, that is the function is basically of t. Now when I'm differentiating with respect to x, I have to have this term, that is dt by dx. Now in my dt by dx, we have not shown basically what the derivative of dx by dt is nothing but phi dash of t. So dt by dx is going to be basically, will be using the formula which is 1 upon dx by dt. Okay, so we know that 1 upon dx by dt is nothing but phi dash of t. So I'll be just simply substituting that. So this becomes xi double dash phi double dash xi dash upon phi dash square into, since it is 1 upon dx by dt, which is nothing but phi dash, so this becomes cube. So you can see that the option is nothing but B. Do let us know in the comment section what do you feel about the levels of questions which we have posted, and also the explanation whether you are understanding or not. Moving ahead with the next question, which is question number 5. We have a function f of x which is given to us as x square f dash of 1 plus x f double dash of 2 plus f triple dash of 3 plus x cube, such that x belongs to a real number set. Now here they have also stated this important thing, that f of x is a polynomial and it is of degree 3. So that's the main important part which is given to us. Now why is it important, we'll see as we solve. Now since we are having the terms which is f dash, which is nothing but the first derivative, double dash which is the second derivative, and triple dash which is nothing but the third derivative, so what we'll do is we'll just simply take derivatives of it, because there is no other way which we can move ahead. So just simply taking derivative, and then we'll figure out what the options are given to us. So taking the derivative, so I'm taking the first derivative, so f dash of x is going to be, so derivative of this, right, x cube derivative first, so this is nothing but 3x square. Derivative of this is 2x f dash of 1 plus derivative of this is f double dash, and derivative of this is basically going to be 0 because it's a constant term. Next, moving on to the next part, that is double derivative. So I'm taking the double derivative, that's derivative of this again, so it becomes 6x plus it is 2 f dash of 1 and derivative of this is 0, and I'm taking the triple derivative, so 3 times derivative, we are getting it as 6. So now analyzing this part, that is f of x is a polynomial of degree 3. This is important because it tells us that if I'm differentiating f of x 3 times, I'll be getting a constant term, and if I differentiate the 4th time, I'll be getting a 0. So that is what we are basically getting. I have differentiated it 3 times and I'm getting a constant term. Sometimes it may occur that the function which is given is not becoming 0. So in that case, you have to understand that the 4th derivative should be equal to 0. So then you can have one more relationship over there. So this is what we basically are getting. So f triple dash of x is 6. So basically I need to find this function. So I have found this triple dash ka term. So now if I just substitute x as 3 in this, so f triple dash of 3 is nothing but 6. So basically I found this term, that is, so one term is down. Now going ahead and seeing that I need for the double derivative or 2. So let's find that thing, f double dash of 2. So that becomes 12 plus 2 f dash of 1. So here we cannot do any simplification, so we have to move ahead. So we have seen this term, let's see this one, that is f dash of 1. So that means basically I need to substitute 1 in this. So f dash of 1 is nothing but going to be 3 plus 2 f dash of 1, and we have f dash of 2 term. We have already found that, so let's substitute that. So now we will be just taking, you can see that f dash of 1 is the only variable, because that is what we need to find, the value of that we need to find, so that we can substitute. So this becomes 3 plus 12, 15. We have a 4 and that goes that side. So it's minus 3 f dash of 1. So we are getting f dash of 1 is nothing but minus 5. So we have found one more term, which is this one. And simply I need to find now this, that is double derivative of function, and substituting 2. So since f dash of 1 is minus 5, I can just substitute in this. So this becomes 12 plus 2 into minus 5, which is basically, you're getting the answer as 2. So this is 2. So now we have the function ready with us, that is f of x is nothing but equal to x cube. Just writing this term first. Then we have the minus 5x square. Then we have the plus 2x. And we have the last one, which is 6. Now let us go see the options. In this is very much important, that is all of this. That means basically this is an indication that I have to check it whether each and every option is valid or not. If all these three are valid, then I have to select option D, because that's the basic trick over here, or basic twist which is given to us. So I need to check for every option, which is A, B, C. If all of them are valid, then I will go for D. If only one of them is valid, then that particular option will be selected. So now checking. So because basically you can see that we have to substitute 0, we need to substitute 1, and we need to substitute 2 and 3. So I'm just substituting x is 0, so I'm getting f of 0. So substituting, you will get 6. X is 1. So substituting, you will be getting f of 1. 1 minus 5 plus 2 plus 6. So you're getting f of 1 as 4. Next, going for x is equal to 2. So you're substituting 2 in this. So f of 2 is equal to 2 cube, which is 8, minus 2 square, which is 4. 4 5s are 20, plus 4 plus 6. So you can see that the answer for this is minus 2. Next we go for x is equal to 3. So that's f of 3. So 2 cube is 27 minus 45, which is for this 5 into 9. 9 5 are 45. Plus 3 2s are 6 plus 6. So after solving this, you get the answer as minus 6. So now let us go for the first option. We have f of 0 plus f of 2. So let's just do the addition of f of 0 plus f of 2. So that's 6 f of 0 plus f of 2, which is minus 2. So you're getting 4. And you can see 4 is nothing but f of 1. So you can see this is maybe a right option. Next we go for f of 0 plus f of 3. So f of 0 plus f of 3 is nothing but 6 plus this thing, so answer you're getting 0. So this is also a right option. So basically when two options are right, that means the D option should be the right option. But just to verify it, it will just take a few seconds. So f of 1 plus f of 3. So that is f of 1 is 4, f of 3 is minus 6, you're getting minus 2. So that's nothing but f of 2. So you can see this is also valid. That means you can clearly go for the option D. So moving ahead with one more problem. So we have if 8 f of x plus 6 f of 1 by x is x plus 5 and y is equal to x square f of x, then I need to find the dy by dx at x is equal to minus 1. So in these type of questions, they will not give you a clear function. Basically, you can see that there is no f of x which is given clearly to us. They have just given a relationship of f of x, a function which is there. So in this case, what we do is, since they are asking us to find dy by dx, so let us just differentiate this and keep it aside. So if I differentiate that, so dy by dx is equal to, so I need to differentiate x square, so that is 2x because it's like a UV rule. this is one function, this is the other function. So 2x into f of x plus x square into f dash of x, because it's derivative of f of x. So this is what we are getting. And now I need to find dy by dx at x is equal to -1. So that's another important thing, that I need to find this derivative at x is equal to -1. That means I have to substitute x is equal to -1. So just let us substitute and keep it aside. So that becomes -2 f of -1 plus -1 square. So that's 1 and f dash of -1. So from here you see that you need to find the derivative of the function, that is f of x, and you have to substitute -1 in that, and you need to also find the function's value at -1. So those are the two things which we need to find so that we get the answer. So let us first concentrate on f of -1. So f of -1 is, you can see from this relation, because we have already used this up. So from this relation, I'm just substituting x is equal to -1 in this, and I'll be getting this as 8 f of -1 plus 6 f of -1. Because it is 1 upon -1, so that becomes -1 is equal to -1 plus 5, which is basically 4. So when you see that, you get addition of these two, because these two terms are same, f of -1. So you add it up, you get 14 f of -1 is equal to 4. So f of -1 is 2 by 7. So you have got one of the values. So let us just write it down. So -4 by 7 is what we are getting, because it's 2 into that. And I need to find this now. So if I want to find a derivative, I need to just differentiate this with respect to x. So differentiating this, I'll be getting this as 8 f dash of x plus 6 f dash of 1 by x into, I need to differentiate 1 by x also. So we know that it is nothing but -1 by x square. So writing it in this format is equal to, on that side we have x, which is 1, and 5, which is 0. So this is what we are getting, and I need to find the derivative at -1. So let us just substitute x is equal to -1. So we get 8 f dash of -1 minus, we have a 6, and this is -1 square, so this is -6 f dash of, again this becomes -1, is equal to 1. So you can see 8 minus 6, which is 2. So f dash of -1 is 1 by 2. So when we substitute over here, we get 1 by 2. So now we have to simplify this. So cross multiply. So -8 plus 7 by 14. So that becomes -1 by 14, which is nothing but your option C. Moving on to the last question, we have if cos x by 2, cos x by 2 square, cos x by 2 cube, and so on, a cos x by 2 raised to n is function, which is f of x, then I need to find the value of this, that is half tan x by 2 plus half 1 by 2 square tan x by 2 2 square plus so on. So now this question for some of you guys will be difficult and you will be directly skipping it out, but we can just use some logic over here. Here you can see that basically there is a multiplication which is present between the terms, which is cos. The cos, different cos terms, you have a multiplication which is present. But in the question, we have the addition which is present. So just asking you a question, that what basically converts a multiplication to an addition. So it's obviously a log function. So what we will do is, we'll basically consider this equation and take log on that, on both sides. So if I'm taking log, the multiplication becomes basically addition. So we have log cos x by 2 plus log cos x by 2 square plus log cos x by 2 cube plus plus log cos x by 2 raised to n is equal to log f of x. So this is what we are getting. Now I need to find this thing, that is tan. So now I need, basically I don't have a log term over there, so I have to get rid of the log. So what I will do is, since you can see in the options. In the options, they have the dash which is present, f dash. So that basically gives you an idea that we have to take the derivative of it. So differentiating this with respect to x. So if I'm taking derivative, so just concentrate on this term. I'm taking derivative of log, so that becomes 1 by, so that becomes cos 1 by cos x by 2. And we need to find the derivative of cos, which is minus sine. So minus sine x by 2. And we also need to then find the derivative of x by 2, which is half. So you have a half term which is present. So in the same format, you will be getting the other terms also. So this becomes sine x by 2 square upon cos x by 2 square with a minus sign and 1 by 2 square. So in the same format, we have all the terms. I'm not solving that. Just going to the last one. So we have derivative of log f of x. So that becomes 1 by f of x. And it is f dash of x. So basically you have got your answer actually. Just showing you what is happening over here. So we have a half. And what I will do is, since every term is going to be having a negative sign, I'm taking the negative sign that side. So that becomes minus f dash of x upon f of x. So, and also here we have a sine by cos. That means it's tan. So we have a half tan x by 2. Here we have 1 by 2 square tan x by 2 square. Same way we'll be having this as 1 by 2 cube tan x by 2 cube and so on. So basically whatever is asked is what you have got. So that means it's option C. So thank you guys for watching our video. Please do let us know in the comment section what more videos you would like us to make on, the different topics you would like us to make on. Do like our videos, do share our videos with your friends, and do subscribe our channel. To never miss a notification from our channel, please do hit the bell icon which is present beside the subscribe button. So thank you guys, keep watching, keep learning, and happy learning. Bye.